Unit 1, Lesson 5, number 81 in the homework. In this word problem, we're going to examine two different equations. They are highlighted in yellow. If we look at the second equation, here, this is going to explain the relationship between lowercase t and capital T, where the lowercase t represents time and the capital T represents temperature. In a lot of word problems, we don't use the same variable, but because one is capitalized and one isn't, please think about them separately. When I look at the second equation up here at the top, we're going to talk about the number of bacteria as being N. The input variable is capital T, which, just like the last equation we talked about, is going to talk about temperature. One thing to note, the inequality that was given is a restriction on the domain. What that means is that the model that is given, n of t, will only work for t values that exist between 1 and 20. So it's a very specific model that only talks about temperature between 1 degree and 20 degrees Celsius. Outside of those input values, the model does not fit. Again, with n of t, temperature, T, is the input variable, and your output technically is going to be N, which is the number of bacteria. If we start with part A, the directions ask you to find N of T. If we go back to our definitions, T of t is going to be our input variable. So what I'm asking you to find is n of 2t plus 1. In this scenario, we go back to the n function at the top. Every place we have a capital T, we are going to replace it with the quantity 2t plus 1. From here, we would use our algebra. We would FOIL out the two quantities, or distribute in other words. We would distribute the negative 20 here, bring down the 600, and combine like terms. Here's an example of what the work written out might look like. Again, from step 2 here to step 3, there probably is another line of work that you need to do. In the next exercise, part B, you're asked to find n of t of 6. If we look at this as a nested function, or a composite function, we can figure out the inner function first. So we would go to the capital T function here, and we would plug in, and we would get 2 times 6 plus 1, which is 13. We then would plug that value back into the n function, which then gives us remember, 2030 is ultimately the number of bacteria produced after 6 hours of time. In part C, you're asked to find the time when the bacteria count reaches 800. So if you think about it, here we are relating T time to N. That's exactly what we defined with our composite function. A function where we took out the capital T, or temperature factor, and we created the relationship between the two, lowercase t and capital N. We found this earlier in part A to be 40t squared plus 590. The question is, what do we do with the 800? Well, 800 is the bacteria count. It's not the time. You're asked to find the time. So you need to solve the equation of 800 is equal to 40t squared plus 590. A couple ways you can do this. By hand, you could subtract 590 from both sides. You could divide by 40 and take the square root of both sides. That would generate two solutions, one positive, one negative, which you would only keep the positive solution because time can only be positive. The second method would be, in your calculator, put 800 in for y1, for y2, put in 40t squared plus 590, and then solve the intersection. When you would do that, either method, you would come up with approximately 2.3 hours. After 2.3 hours, there would be approximately 800 bacteria.